Okay, so welcome back. Now I'm going to do this example. So this is an example of a particle that's moving at a velocity described by this linear function with respect to time. So what it says is, given the velocity function v of t equal to 3t minus 5 meters per second, a particle in motion from time equals t equal to 0 to t equal to 3. So we're interested in this time period. It says find the net displacement of the particle. Now net, it's kind of redundant because displacement assumes net, but anyway. Okay, so we want to use the net change theorem, right? So to find the net change, we're going to use, now again, which formula we use, and I didn't mention this, but which formula we use in the net change theorem depends on the problem, right? So since they want the net change, what we're going to use is we're going to use this equation. We're going to use a to b of f prime of x dx is equal to f of b minus f of a. Okay, so that's going to be equal to the derivative, or the integral, from 0 to 3 of the derivative of the integral function. So that's going to be the velocity function, right? So this is going to be 3t minus 5. Right? dt. Well, in this case, let's change these to t. Okay? And now, that's going to equal, now what's the antiderivative? That's what we need here. So the antiderivative is 3/2 t squared minus 5t. And we're going to evaluate this from 0 to 3, right? And so now what I'm going to do is now I'm going to evaluate this at 3 minus this evaluated at 0. Now notice at 0, both terms are just going to go to 0. Okay? So realizing that, I'm not going to write that part down. Okay? So I'm telling you now, just be observant here. So this is going to be 3/2 times 3 squared minus 5 times 3. Now the thing is like I said, this is going to be I'm going to subtract off 0 because at 0, this whole thing becomes 0. So it's just 0. And so now what happens to this thing? This thing becomes what? 27 over 2 minus 15, which is the same as 30 over 2, which is going to equal negative 3/2. And since this is in meters per second, we know that this is going to be in meters. Okay? So, in other words, the net displacement of this particle is negative 3/2 meters, or negative 1.5 meters, okay? Or 1.5 meters in the negative direction is where it is from its starting point. Okay? Now, what if I wanted the total distance that the particle moved? Well, then I'm going to have to use the absolute value, and I'm going to have to find where this function is 0. Okay? I have to find out where is the velocity 0, because that's when the particle stops and possibly changes direction. So let's start over and let's do the same problem, but this time instead of net displacement, let's find total distance. So the first thing I need to do is I need to set the velocity equal to 0 and find out where this velocity changes from, stops, where the particle stops. So then that tells me that t is equal to 5/3 seconds. Okay? Or 1 in 2/3 seconds. Okay, that's when the particle stops. So, and I'm just going to use 5/3 because that's going to be easier. So now, guess what? That's where I'm going to split up my integral. Okay? So this is where I'm going to have to take my interval from 0 to 3. I'm going to split it up into two intervals. 0 to 5/3 seconds and 5/3 to 3 seconds. Okay, because that's where it changes direction. And so now when I set up my integral, I'm going to go from 0 to 3 of v of t, right, dt. And now I'm going to split this up into two intervals, 0 to 5/3 v of t. And I'm going to absolute value of that plus the integral from 0, oops, excuse me, not 0, 5/3 to 3 of the absolute value of vt dt. Why am I using absolute values? Because I want to add all of the distance traveled. Okay, I want total distance. Okay, so now I'm going to do this. So now I know this is going to equal what? It's going to equal, again, this is going to be 3/2 t squared minus 5t evaluated from 0 to 5/3 plus this is going to be 3/2 t squared minus 5t evaluated from 5/3 to 3. Okay, now so since it's negative over this interval, okay, it's negative over this interval, positive over this. Since it's negative over this interval, I'm going to take the negative of this thing. Okay, because since I need to take the absolute value, it's positive over this interval, so I don't have to do anything to that. Okay, so now let's evaluate. So this is going to be negative 3/2 times 5/3 squared minus 5 times 5/3 minus 0, right? Because it's just going to be 0. So I'm taking the negative of that whole thing, right? So this whole thing is equal to this whole thing. I'm taking the negative of it. Okay, so you just be careful when you're writing things out that you're careful and try to be meticulous about what you're writing down so you don't make any mistakes. Now I'm going to plus, now I'm going to add, now this is where, now I got to take care of this part. So this is going to be 3/2 times 3 squared minus 5 times 3. Now I'm going to subtract off 3 halves times 5 thirds squared minus 5 times 5 thirds. Okay? And I'm going to add, so I've got a lot of braces going on. Okay, so now let's simplify. Okay. This is going to become what? This is going to become 75 over 18 minus 25 over 3. That's 0, so that goes away. Okay, and I'm going to distribute the negative sign now to this. So this is just going to be negative, and that's going to become positive. And so now I can drop these braces. So I've taken care of that part. Now, plus, now I'm going to take care of this. This is going to be 27 over 2 minus 15. Now, this is going to be minus, so let me put a bracket here, minus this whole thing, which is what? This is going to give me 75 over 18 minus 25 over 3. Okay, so far so good, right? Okay, so now let's go back up to here. I can erase this stuff now, I don't need this. Okay, so now, what do I have now? This is going to give me, well, I'm not, let me hold off before I start doing anything with that. So negative 75 over 18 plus 25 over 3 plus, now, this gives me what? 27 over 2 minus 15. Now I'm going to subtract off this. So it's going to be minus 75 over 18 plus 25 over 3. Okay. So now, look at this. So I've got this and this, so this is going to be doubled. So this is going to be negative 150 over 18. Plus, this is going to be doubled, so this will be 50 over 3 plus 27 halves minus 15. Okay, so now this is where, so I can, let's see here. This is divisible by 6, and this is divisible by 6. So that's going to give me a negative what? 25 over 3 plus 50 over 3 minus, let's do this as 45 over 3, right? 15 plus 27 over 2. Okay, so what do we got? We got minus 25 and minus 45 is going to be 70 So minus 70, which is going to give me a minus 20 over 3 plus 27 over 2, right? Which is going to give me a negative 40 over 6 plus what? 81 over 6, right? 3 times 20 is 60, and 3 times 7 is 21, so that's 81. So yeah, so now if I subtract these, guess what? I get 41 over 6. Okay, so let me check. What did I get? Or what did they get? Okay. So, the total distance traveled is 41/6 meters, or what? This is going to be 6 5/6 meters. That's it. Have a great day.